Welcome to Vintage Radio Cafe, your number one channel for relaxing vintage audio restoration. If you like watching an idiot wielding a soldering iron, you've come to the right place. Watch Ray's attempts to fix wonderful forgotten radios from another era, way before transistors. Sometimes he even gets them working again. What could go wrong, right?
Hello again, everybody. So it's the next day. That would be the fourth day working on the radio per se. And yeah, as you have seen, yesterday I worked most of the day on replacing the power switch. And yeah, it was important for me. Although I could have made my test with the direct makeshift connection that was made, but yeah, David gets a kick out of that because I'm so afraid of high voltage all the time. I try to do everything as safe as I can for myself and for not burning the house down. So let's test this on the dim bulb. Okay, I'm confident enough at this point to give it a bit of power, so close to 120. I've already hooked up the multimeter to the rectifier. So let's see what we get. Is the power on? No, it's not. It's a very big setup because the speakers are connected with a big connector. There's so many pins. I'd rather move the cabinet close and use the original cable and connect it correctly. I've got an aerial for the FM, and yeah, I'm gonna test the recorder, see if I have output. So I've got a little MP3 player here, and I'll get it started because it turns off by itself. I just want to get this ready. So let's try AM. So the dim bulb reacts normally, brighter and then dimmer. On restricted voltage at 119, we are getting well, you might not see it, but 119 volts coming in, and it's the power consumption in watts is like close to 33. The rectifier started higher, it's going lower. The target voltage, DC voltage from the rectifier should be 260 and 265, depending if you're on medium wave or FM. So we're getting 175-ish. I don't expect to get any sound. The bulbs, the pilot lamps are of course dimmer, and besides I didn't have the 7 volts one. I just have 6.8 on hand. So let's see if we get any output. Okay, so the speaker, the volume pot is scratchy. Volume is turned up pretty high. Nothing, not even a scratch. Let's try FM. Yeah, when your voltage should be 260 and you only have 173, usually those radios don't work at such a low voltage. So let's switch it to full power. We'll see the voltage go up. So I'm close to 120, 119. Whoops, I hit the tripod. Silly me. So do we have more? Scratchy. So the the preamp and amp section, you know, on the audio part has some life. Still nothing on the radio side. Okay, let's try shortwave 2. Moving the antenna won't change anything. Shortwave 1. Let's go back to AM on full power. Activate the antenna. Try to find the station. Nothing, right? Absolutely nothing. Moving the antenna doesn't change a thing. Okay. What I know about these the valves inside, they're all weak, okay, but they should give me an output, you know, to an extent. But the EF85 is completely dead. So I don't know much about the EF85. I don't have any on hand. I never used them in any radios. So they weren't part of any of the other chassis I've worked on so far. The description of it is it's a RF pentode intended for what is it? Wide band amplification, I believe. So it has to do with the RF. So I don't know if it can explain the dead bands all over by itself, but it certainly doesn't help. So the power consumption, as you can see on the other meter there, maybe you can see it's 51.33. This radio should pull all the way up to 75 watts at maximum. Okay, so it's not bad now. The rectifier is at least a good 20-25 volts too low. Okay, and let's try just to make sure the preamp and amp are working. Let's try it on yeah, I'll have to restart this again. Probably my batteries are low. Let's try it on tape. Let's put volume here. It's just a little MP3 player, okay? And always remember, guys, when you're testing your phono and tape recorder input, never put anything else but a turntable on the phono, okay? Because it's not made to receive the same voltage, the same higher 1 volt voltage. This is for the millivolts range. So you'll only get a hum. So use the tape, use your cell phone or whatever. Okay, the sound is very weak, very distorted, but the preamp and AM audio sections are working. Now, the poor quality of the sound, well, I believe it's all aside from the vacuum tubes, it's all the capacitors, all of them, I'm pretty sure. And there's capacitors on the speakers themselves. They look pretty beat up, so it wouldn't surprise me if they were dead or close to it. But yeah, so it's a good start. Like I always say, let's turn it off. Let's turn this guy off. As I always say, when you get output on a radio you know nothing about, you start working on, it's always encouraging. It's always a good start. Now, the other thing I always check is how the main filter caps the electrolytics discharge. So this has to go down to 0. So it went down to 9. And now it's getting back up. Okay, that's not a good sign. It's supposed to go down to 0 fairly quickly. So either two things. The electrolytics are not connected right, or they're just gone. They're so leaky. There's so much DC in there. That's what I'm thinking. And guys, correct me if I'm wrong, but usually when I change the big filter, the big smoothing caps, after that, it stops getting erratic. It goes down. So now it's going up again. So remind me when I start working on it and I restuff that cap to discharge it before. See, it won't stop going up and up and up. And there's no power going to the radio whatsoever. It goes back up on its own. Oh yeah, that's not normal. I don't want to touch them, touch the leads, and I don't know. Where will it stop? 20, 30 volts? I don't want to touch them. So that's my starting point. Okay, and as I always do, I will identify. That will be job 1 for today. Identify all the parts, all the components. You know, get the schematic next to it, and I put stickers on everything, so I know the values, I know the numbers, and then I compare everything with the schematic, make sure I have the right thing. If there's a difference between what's written on the schematic and what's the actual value in the chassis, I take note of that. And then I start ordering the valves, the capacitors, whatever I don't have. In this case, I mean, those capacitors, as old as they are, I've never seen those Eero caps so clean. But they're certainly all leaky, I'm sure. On the bottom of the chassis, which you can't see right now, there's also a mix of Eero and Wimas, the infamous Wima caps, paper caps. And yeah, they don't look too hot. I've seen worse, but yeah. So that's the plan for today. And I'll get back to you when I start working under the chassis. Last thing I forgot to mention. I don't know if you can see this, but since I wanted to test with everything in circuit, with the speakers and with the stereo decoder, well, it was easy to remove the decoder and just, yeah, I just taped it to the back and it's connected to the back of my chassis holder. So for once, this big, bulky, cumbersome wooden chassis holder is useful. You know, see, now I can have it right here. I don't know if you can see it. Maybe, yeah. Let me frame you a little bit better. That's all the way in the back. Yeah, that gray can there, gray box, that's the stereo decoder. So this in itself might require some work, most likely, in fact. I don't know how it's made. I don't have it on the schematic. I don't know if there are, I don't think there's any valves in there, but there's certainly electrolytics, caps, resistors, and all that. So that'll have to be checked, and I just have to be mindful of that because some of the problems might come from there. So yeah, there you have it. The switch has been a bitch to clean. I've never seen this. There was at least 1 or 2 mil, 1,000 of an inch or 2,000 of an inch thick residue of I don't know what. It wasn't conductive, so it was probably a mix of bits of bakelite from the switch itself, pieces of metal, maybe microscopic pieces of no, maybe not metal, but dirt, plastic, and stuff like that. Wasn't conductive. Was super hard to remove, as you've seen. Honestly, it would have been a lathe job, you know, a job that you do on a mill, and with a little knife there, you just grind away that kind of dirt at that thickness. But I did it with sandpaper, and yeah, the switch works. So it looked good when I was done. Very happy with that. But no, it's identifying all the parts. So I'll get back to you as soon as I can, guys. Yeah, take care. Okay, folks. So we're back. It's it's the end of the 5th day. It's late at night. Would you believe I spent all day just working on identifying all the parts, all the components on the chassis, and correlating with the schematic. It was really, really a pain. This radio is crammed with paper caps mostly. Look at this. I usually have one and a half sheet of parts. Look at this. And it's pretty much organized for the way I'm going to be working in the right order that I'm going to be working on the radio. So I already ordered all the vacuum tubes. There's 9 tubes. I ordered 8 because one of the ECC 83, I think it'll be still good enough at 81, but the other ones are pretty weak. One of the ECC 83s, that's 60, so that's too low. As you know, the EF 85 is dead, and thank you to David who schooled me on the function of that pentode, and it amplifies. It's between the two IF cans, so it amplifies all the wave. So it's normal. I'm not having anything on the radio side, so that makes a lot of sense. The electrolytics on the chassis and electrolytics on the speakers, 2 big 250 microfarads, only 10 volts, but they're pretty big, and I have to mind the fact that they are non-polar. Then all the paper caps. On top of the radio, there are only those caps. 1, 2, 3, 4, 5, 6. Yeah, 6 caps sitting on the twin output transformers, and all the rest are just paper caps, mostly around the vacuum tubes. Very, very hard to identify. Some, I've put in French inconnu, unknown, because I couldn't figure out the exact numbers on them because there's so many 0.01s. And what they did is some of them are directly connected to the vacuum tube, to some of the pins of the vacuum tubes on one side, and where they didn't have enough room to do it, they just put a vertical board and they ran some wires there and they put the capacitors there. So it was a nightmare to find. On the volume pot, nothing very special, just 0.1 UF, 100 volts, 100 volts AC, 250 DC, but they're shielded. So I'm really going to check them, and if I can avoid replacing them at all, I won't. If not, I'll have to do the usual shield thing with the ground wire, extra ground wire. And after that, I've identified the components inside the stereo decoder. I managed to find a schematic, not for the exact same model, but it looks almost exactly the same, probably just a different year. So I think the paper caps are going to be okay because they're plastic, they're not paper. But the electrolytics, I measured one of them, I pulled one, and they should be 100 microfarads. The one I checked was 136, something like that. The rectifier, as always, I'll use one of Manuel's boards from PCBWay. And there is also one separate, another vertical PC board, which I won't be able to move because it's on, I think it's on the volume. Yeah, it's on around the volume pot. There's a board there around the volume pot, and there's 10 capacitors right there. Of course, I'll need new pilot lamps. I'm using 6.8 volts now, but they should be 7 volts. And the piano key, that was interesting. piano keys the exact same size, width, height, and depth, but the inside the socket is not the same, so it won't fit. So I'll have to go and meet up with the seller because he has a bunch. Maybe I'll find one that fits. That's going to be a problem. But yeah, I've never seen so many caps. Got to be honest with you, it's a very, very complicated, maybe one would say over-engineered radio. Yeah, just the stereo decoder itself. I hope replacing the electrolytics is going to get it to work. I hope there's nothing wrong with it. It's pretty clean inside though, and there's no vacuum tubes. So that's that. There's two transistors. I'll have to check them. They look good, but hey, you never know. So yeah, I figure I'll need at least 7 to 10 days just to do the recapping. There's no way you can do 20 or 30 or 40 caps in one day. I can't do that. It takes too much concentration, and yeah, I'll have probably to move so many things. And yeah, I already have had to move the connector board in the back to access two of the WEMAs. One is completely destroyed. I mean, it's not just cracked, it's destroyed. I can see the inside. It's open. I mean, open, physically open. So cracked that I can see inside down to the wire. So, hey, no wonder this radio wasn't working anymore. There's a lot of problems. I did check some caps, and the paper caps are anywhere between 35 and 51% too high. So they have to go. I don't even have to check the ESR. I know they're leaky after so many years. So I'll keep you posted as I go along. I'll probably start working on it when I get the components. It's Thursday, so even if I place my order on DigiKey over at DigiKey tomorrow, Friday, I won't get anything before Tuesday. So, and the vacuum tubes will take 2 weeks to get in. So that will give me time to recap the radio and perhaps start working on the grill cloth and the cabinet. So yeah, I'll keep you posted, guys. But I've got my work cut out for me, let me tell you. This is not going to be an easy one. Again. So catch you later. Good morning, everybody, and welcome back. So it's been a couple of days since I last worked on the Othello. I started recapping, and yeah, let me show you what I've done so far. So I started with the caps on the twin audio transformers, the outputs, and I redid all those caps. That was easy. And yeah, then I turned the whole chassis around and I started working on it. And yeah, let me show it to you. So here's the bottom side of the chassis, and I started by doing the easy ones first. All those caps that were easily accessible I replaced. Okay. And yeah, then I had to go around the vacuum tubes, and it was really a bitch, I won't lie. So I had to remove this connector board, lift it up, and yeah, as you can see, it's still mounted on it loosely. So I had to go underneath and replace the caps. Yeah, it'll be more obvious to look at on the pictures. And some of the caps were mounted almost directly on the vacuum tube socket, and let me show you one of them. Yeah. Not kidding, guys. They were touching, okay? The socket. Look how melted it is. It's incredible. And it's still, it's still a capacitor. It tested like 31, 32% higher. But hey, you think it's leaky? I would say so. So they had to go. They were a bitch to replace. The new ones are smaller. The leads are longer, so they're moved away from the sockets, so they shouldn't melt again. And yeah, a lot of work still left to do. All this area here, there's a vertical board there with a bunch of just regular caps. Maybe this one's an electrolytic. I couldn't see the value. Very, very hard to locate on the schematic. But what I want to do today is this board. This board alone contains 10 capacitors connected to the volume and balance control. So yeah, there's 10 there. And I won't lie, yesterday I dismounted this switch pack, okay, unsoldered all the wires. So once this was removed, I had a better access to the top, less wires in the way. And yeah, as you can see the leads here, okay? But at the bottom, the leads are practically non-existent. They're really, really short. So there's no way for me just to snip them, cut the leads and try to put new capacitors in. This board it's impossible to remove, okay? There's the way it's connected, the whole, there's three pots there for the volume and balance control. I imagine, yeah, one for the left side, one for the right side, then the balance and all that. And yeah, the board goes around that, and just trying to remove that would mean to take half of the radio apart. Not kidding you. And the tuning strings and all that, it's out of the question for me. So what I was thinking to do, the board, you can see it very clearly here. It's pretty straightforward, okay? 10 capacitors, a few resistors. And what I'm planning to do today is, I just want to split them. I'm going to cut them in half, remove all the middle part of the capacitors, and hopefully get enough leads, long enough remaining leads to be able to reconnect new capacitors. So that's the plan for today, because I'm not kidding you. It's going to take the whole day, I'm sure of it. So I have all the capacitors, everything came in. I've even got the vacuum tubes in yesterday. So yeah, all of those capacitors, those that I've used already, those are waiting to be installed. Vacuum tubes, I didn't even open the box yet. Yeah, all in good times, right? So I do want to replace as many capacitors as I can, because so far I've got maybe 19, 20 done already. They all test incredibly high, anywhere between 30 and 50% higher. So I know they're leaky, and if not melted, they're leaky. So they have to go. First test I didn't have any radio on, assuming it was caused by the faulty EF85. But that alone cannot, explain the whole radio not working. I know the amp preamp is working. I've showed you this. Transformer is okay, the new switch is in, so yeah, it's not, I don't think it's only the EF85, I think the caps, namely the ones that were melted on the EF84, that would certainly explain why the output was so weak, you know, come on. And I checked the resistors around it, around all that, yeah, the output valve area. I checked all the resistors and they all checked okay. So at least, you know, that's a good news. So I'll be back once I'm done with this board. Yeah, got a fresh pot of coffee and everything set up to start working on that. So catch you later, guys. Okay, so we're back about an hour and a half later. Part one is done, which was to remove all the old capacitors from this board. I straightened the pins. I didn't have to split the capacitors in two, just one that I had to cut maybe 1/4 of an inch before the end of the capacitor to have enough leads. But yeah, I managed to be able to cut just on the leads. And I've got one installed. I still have to solder it. But this is the idea. You made a pigtail on the yellow cap there. You make a pigtail connection on each side. And then you put a little bit of flux and you solder that in place. So the bigger ones on that side are going to be easy. Some smaller ones are going to be really tedious to do. I don't have much leads at certain places, especially down here. Really not much. Yeah, I hope I have enough to work with. But that's the idea, guys. So I'll be back once I'm done. Stay tuned. Okay, people. So I'm back. And this is the result. All 10 capacitors have been changed and identified. Put the stickers, you know, inwards so I can see all the numbers. If there's ever a problem, it should be much easier to troubleshoot. Hopefully everything will work. The connections are, yeah, they're sound, they're okay. It's not as good as you know, being able to you know, just insert the wires and the leads in the holes, but it's the next best thing, I suppose. Not much more I can do. And yeah, I'm just going to take a break. Just removing them took me an hour and a half and over 4 hours to put them back on, the new ones. Yeah, so it's a 5.5 hour job just for that. So now I'm going to start doing the remaining ones. I don't know, there's maybe 15 left. Then I also have to do the stereo decoder. There's 4 electrolytics inside. So I don't know, between 15 and 20 capacitors left. It's yeah, I've never seen so many in a radio, in a German radio like that. It's the biggest amount of capacitors I've seen so far. I've only been doing this for like 4 years, but still, it's maybe my 12, 13 radio, something like that. And yeah, I don't know what to think. Over-engineered or just better quality? I guess we'll see if I ever get it to work again. We'll see which case it is. So yeah, I'll take a break and come back to it later this afternoon. Stand by. Okay, folks. So I'm about 3/4 done on the recapping of the chassis, and I'm down to the part, the most difficult capacitors to do. So I'll try to show you this if I can. Yeah, this is one of the ECC83 socket. So we see it from the bottom. And yeah, believe it or not, there's a cap here. A little 100 puff high voltage though, but a small tiny cap, and it's connected directly to the socket on those 2 pins. And yeah, there's no way I can just, like what I usually do, cut the leads on each sides and do a piggy tail connection. So what I have to do is unsolder the white and blue here, so I get access to the lead that's going there, and then unsolder this one. But this one is a double one, okay? There's a green and a red, and they're both connected together, okay? They're assembled like that. So I'll have to unsolder this side and hopefully, you know, remove the capacitor and resolder the new one, which is really small. And yeah, so small. Look at this. 100 picofarad nowadays are this big. This small, I should say. Try to yeah, compare it to the size of my finger. This is incredible. So I had to, the leads are super short, so I had to take some capacitor leads, solder them together, and then I have to try to put this, yeah, back in circuit here if I can. And the one of the problem is I cannot heat it up too much, the soldering point, because, well, because those are miniature sockets for miniature valves, and they're plastic, maybe Bakelite, but I think they're plastic. And yeah, the risk is that if you heat up one of those contacts too much, it melts the plastic around and the connector becomes loose, and or it, even worse, it can break, it can crack it, it can crack the whole socket. So really tedious work. I already replaced one. Yeah, this one, Z-320. Now you see the leads that I made longer. That's not touching anything, so I think it's going to be safe. And yeah, really tedious. And you know, to be able to access that, I had to remove the switch connector. There's one on, you know, each side, those on each side, sorry. So I had to remove this and then unsolder, I think it's 6 wires there, plus this loom. Also had to unsolder it from this connector strip. Yeah, this, all those tabs there. So I took like a zillion pictures to make sure I resolder everything in place, in the right place. So yeah, I'm going to try to do this. I don't think I'll be able to show you any footage. Yeah, those are the tabs here. This is where I have to solder there. 1, 2, and 3. I have to leave one free. I have to put another small capacitor there. It's I'm telling you, it's the worst chassis I've worked on so far. Not because it's, you know, that complex. It's just that there's so many wires, layers and layers of wires before I can reach any of the components. Usually I can get away with, you know, just removing a few, just putting aside a few wires, but not in this case. I really need to unsolder. So yeah, once this operation is done, I'll reinstall the switch pack, reconnect everything, but not before I also change those 2 guys. There's one here, yeah, one there. Those 2 guys are shielded, so I have to assemble, you know, create another well, 2 shielded capacitors, unsolder them from the where they're soldered instead of cutting them like here. No, I'm sorry, all the way at the bottom, and what is it? Yeah, where they join here. So I have to unsolder those and those, and yeah, hopefully I'll be able to reconnect everything in the right spot. But what a mess, what a mess. So I'll be back when I succeed. If I succeed this, I'll show you what I've managed to do. Yeah, catch you on the other side.